record on the computer. So I'd just like to thank everyone that was able to join. I know some of you might have to leave early so that I won't be able to answer all of your questions before you go, but there will be a recording. And the recording will be on Top Hat. It'll be under Virtual Exam Review 3 or Virtual Exam 3 Review. And it'll be underneath all your comments. So that's where the recording will go. And then any solutions that I write out on my iPad, I'll capture those and put those solutions in here as well. So it's really cool to be able to go through that. Now, there are some of you that have responded to the questions on Top Hat. And so I'd like to go ahead and start with those. And then if I can get through the rest of them, I will. So we're going to start off with going through problems 2, 4, 9, 14, 16, and 17. So let's go ahead and get started on Alex with this sample test 3. So we'll start with number 2. Find all the solutions on the equation on the interval from 0 to 2 pi. And then there was a question about comparing some of these answers. I don't know if it was 2 and 9 or 9 and 14, but on this particular problem, it's asking you on a specific interval. So since this is a quadratic equation, when I say quadratic, it has degree 2. There might be 2 answers, there might be 4, but they're not going to be infinitely many. They're not going to be multiples of k. When there's not this restriction on the interval, that's where you're going to have that multiple of k. So let's go out and begin this first problem, number 2, on Top Hat. So now that I have the problem copied out onto my iPad, let's go ahead and begin solving for it. We want to isolate the trig function by adding a 1 to both sides and then dividing by 3. So we'll have cotangent squared x is equal to 1/3. And then when we take the square root of both sides, we get the cotangent of x is plus or minus the square root of 1/3. We can simplify the right as the square root of 1 over the square root of 3. But the square root of 1 is just 1. And so we get 1 over root 3. So we're really looking for a angle x such that when I take the cotangent of that angle x, the adjacent over the opposite, and you might be saying, well, why did you know that it was adjacent and opposite? Well, if you recall from the very beginning of the course, the adjacent and opposite was always a cotangent function. So we want the adjacent side and the opposite side such that it's either going to be 1 and positive root 3. So the adjacent side would be 1 and positive root 3. Or that can also happen when I'm in the third quadrant, where I have -1 and minus root 3. And the reason why is if you take the adjacent over the opposite, you're going to still get positive 1/3. But it can also happen where it could be in the fourth quadrant, still root 3, but this will be negative. And the adjacent is 1. And that'll give us the case where we have -1 over root 3. And that'll also be the case when we're in the second quadrant. So we still have -1 as the adjacent, but the opposite side is root 3. So basically, we're going to get 4 possible answers for this one because of the fact that it's the cotangent function. If it were maybe the sine or cosine, no, I think we will still get 4 answers. Yeah, I do. All right, so which trig function has 1 as one side and root 3 as another? Well, if you recall with the 1, 2 square root of 3 triangle, that meant that it had a side 1 had 30 degrees, side 2 was 90 degrees, that was opposite the hypotenuse, and root 3 had had angle 60 degrees. And so we know it's going to be a 30, 60, 90 right triangle. So that I know that this angle x could be 60 or 30, you tell me. Put it in the chat. So the angle that I've drawn from the positive x-axis here, would that be the 60-degree angle, or would that be the 30-degree angle? Because the 90-degree angle has the two opposite of it. So I'm going to check the chat, see if I got any answers. Crickets. Well, it turns out root 3 is the bigger side. Root 3 is about 1.732, and that's bigger than 1. So therefore, root 3 is going to have the bigger angle opposite. So that's going to be 60 degrees. I always memorize that the cosine of 60 is a half. So 1 over 2. So I know this is going to be 60 degrees. So they're all going to have reference angles of 60 degrees. So I'll call that alpha. So I'm going to have 60 degrees for the first one. And then I'm going to have the, one where it also has a reference angle of 60 degrees. So let's write that down. So that means that theta can be 60 degrees. That's going to be for quadrant 1. And then for quadrant 2, it's always going to be, the reference angle is going to be 180 minus 60 degrees, which is equal to 120 degrees. And then for quadrant 3, theta is going to equal 180 degrees plus the reference angle, 60 degrees, which gives me 240. And then for quadrant 4, it's equal to 360 minus the reference angle. And that's going to give me 300 degrees. So I think they want these answers represented in radians. So we had 60 degrees, 120 degrees, 240 degrees, and 300 degrees. So if we want this in radians, it's going to be pi over 3, because 180 divided by 3 is 6. Or 18 divided by 3 is 6, so it'll be 60 degrees. And then 6 goes into 12 2 times, so that's going to be 260 degrees, or 2 pi over 3. And 6 goes into 24 4 times, so that'll be 4 pi over 3. And 6 goes into 30 5 times, so that's 5 pi over 3. So those are going to be the answers for x. So x will be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. All right, so let's go and plug in our answers on Alex. So checking our work. Woohoo, we got it right. All right, so the next one under my notes was number 4. So let's check out number 4. So here there's no interval. So that's why on this particular case, you're going to have infinitely many solutions, because it's not saying on the interval from 0 to 2 pi. So for number 4, we have cosine squared x plus 2 cosine x equal to 3. So I've copied that out onto my iPad. So let's go ahead and share that. So the first thing I'm going to do is write it in standard form. In the last case, we had something squared equal to a constant. In other words, we didn't have a cotangent that was linear. So for that one, I isolated the trig function. Here, the cosine occurs twice. So I'm going to rewrite it so that I have 0 on one side and everything else on the other. So I'm going to subtract a 3 from both sides. So I have cosine squared x plus 2 cosine x minus 3 equal to 0. So I asked myself, what are factors of 3? That means I want numbers p and q that'll equal -3. I said factors of 3. I meant to say -3. That'll add to 2. So in other words, I want P plus Q to equal 2. So when I do that, I say, well, there aren't that many factors of 3. There's only 3 and 1. Only thing I have to worry about is the sign. And so it looks like I need the negative to go on the 1 because 3 minus 1 will give me 2. And I have to have one of them negative because 3 and -1 will give me -3. So therefore, P would equal 3 and Q would equal -1. All right, woohoo, so put a little smiley face. So now that I know the magic numbers, I can factor it. It's going to factor into cosine x plus 3. And I get the plus 3 because I have a positive 3 here. So that's where the plus 3 comes from. And then I'm going to have cosine of x minus 1. Both of those factors are going to equal to 0. So now that I factored it, I want to set each one of those factors equal to 0. So in the first case, I'm going to have cosine of x plus 3 equaling 0, or cosine of x equaling -3. And that's an impossibility. The cosine graph, if you recall what it looked like, the cosine graph had an amplitude of 1. That was the coefficient of the cosine. So it meant that it started at 1. It crossed at the quarter point, it went down, and then it crossed back again, and then it topped out at 1. It bottomed out at -1. So if that's the case, how on earth, sorry, that's supposed to be an eraser, how on earth is it going to ever be -3? The values that it bounces between are -1 and 1. It's no x value that'll give you a -3. So therefore, this is impossible. So it's no solution. So let's take a look at case 2, where we set the second factor equal to 0, cosine x minus 1 equal to 0. And that's the same as saying cosine of x equaling 1. We're going to use the unit circle for that one. So I'm going to pull out my trusty dusty clip art on Explain Everything. Just love this little app. I think it's the bomb. So I've got my little unit circle there, and I'm really asking myself, find values on that unit circle, the x coordinate, such that the x coordinate is equal to 1. So here is the ordered pair. Oops, sorry. Here's the ordered pair, 1, 0. That x coordinate is 1. So let's highlight that. And that means I haven't moved at all in terms of an angle. So my angle is going to be 0. If it had said cosine of x equal to 0, then I would be looking at the ordered pairs 0, 1, and 0, -1. And so if that's the case, then I would say, oh, there's 2 places where that occurs, and I'll highlight it in blue. That would happen when x was pi over 2 or 90 degrees. And then I'll highlight the next one in red when x was equal to 3 pi over 2 or 270 degrees. That would give me cosine of 0, but they don't ask us that. So just know that whenever they give you values of 0 and 1 for the sine and the cosine, those are going to be quadrantal angles. That means they're going to lie on the axes, either the x-axis, positive or negative, y-axis, positive or negative. If it's cosine, you want the x value. If it's sine, you want the y value. All right, so let's go ahead and erase that because we don't need that for this one. So let's erase all that, so we don't get confused in our write-up. All right, so x is 0. So the only solution for this one is x equal to 0. They do not give you the calculator on this one, so you have to know the quadrantal angles. And that means if you draw the unit circle, that's totally fine. I used to visualize it in my head. I would say, okay, cosine 0. Okay, cosine of 0 is the x value. So where are the x values 0? Oh, that's going to be, the x value is 0. No, that's here. The x value is at 0 equal to pi over 2 and 3 pi over 2. So I would visualize it, but you can always draw the circle. All right, so let's check our work. Uh-oh. Oh, I'm sorry. It's infinitely many solutions. So sorry. So then I've got to add multiples of 2 pi. And you say, well, why do you add multiples of 2 pi? Multiples of 2 pi because the cosine repeats every 2 pi rotation. So, I mean, the period is 2 pi. So it should be 0 plus 2 pi k, but it doesn't make sense to say 0 plus something. So we're just going to get rid of the 0 plus and just put 2 pi k. Eek. All right, super. All right, so now let's go on to number 9. So number 9 is cosine 2x minus root 3 cosine x. And I think there was a question about this out on Top Hat. So let me go out and read that question again so it's fresh in my mind. So I really appreciate you submitting this. So I think there was a question about 4 and 9 that was asked. Also on number 6, how the heck do I tell that it wants me to do multiple answers? It looks exactly the same as the one where it only wants one answer. It depends on the trig function and the value. Yeah, so I'll take a look at number 6 too. Matter of fact, I'll come back to 6 after I do 9. All right, so for number 9, we have cosine of 2x. So let me share my screen so you can see that. So number 6 says cosine of 2x. Excuse me, number 9 says cosine of 2x minus root 3 cosine of x is equal to -1. So we have cosine of 2x minus root 3 cosine of x plus 1 equal to 0. So again, I've written it in standard form. So let me share that on my screen. So I added a 1 to both sides. And the reason why I did that is because I wanted to write it in standard form. And you said, well, wait a moment, there's nothing squared. Well, with the double angle formula, there is something that's going to be squared. For the cosine of 2x, there's 3 formulas. I'm only going to focus on 2 of them. Cosine of 2x is equal to 2 cosine squared x minus 1, or 1 minus 2 sine squared x. And you might be saying, man, how do you have all this memorized? I really only have one of them memorized, the one we're not going to use. I have this one memorized, cosine squared x minus sine squared x. And really, to be honest with you, I don't even really have that one memorized. I really have this memorized, that cosine of a plus b is equal to cosine a, cosine b, because I remember couscous. Like the little rice couscous. It's not really rice, but it's a grain. And then sine A, sine B. I really do have that one memorized. Cos. And then I memorized that the signs are opposite. Well, if A and B are both X, look at this. Shut up. You have cosine X plus X. Then it's cosine X, cosine X minus sine X, sine X. I just let A and B both be X. But x plus x is just 2x. And then cosine x times cosine x is cosine squared x minus sine squared x. So really, that's how I am able to call up the cosine one. So once I know this one, which is cos squared minus sine squared, because I know this part here, then I know that this must be the one where the 2 cosine squared x comes first. You go, wait a moment, where are you pulling that rabbit out of the hat? Well, I do know this. I know that sine squared plus cosine squared is equal to 1. So I'll put that in a little thought cloud as well. So put this in a little thought cloud. So I'm going to put in a little mini cloud over here. Don't laugh at me. So I have sine squared x plus cosine squared x equals 1. That one I do need to memorize. So I would have that one memorized. And then what I'm going to say is, well, wait a moment. If that's true, what about if I subtract the sine squared from both sides? If I subtract the sine squared from both sides, then I'll have cosine squared is 1 minus sine squared. Similarly, if I subtract a cosine squared from both sides, then I'll have sine squared x is 1 minus cosine squared x. And that's what I'm going to do. I'm going to replace this formula here where it says the sine squared x. I'm going to put in that 1 minus cosine squared x. And when I subtract, a negative minus a negative is going to give me a second cosine squared x minus 1. So that's why I know it's going to be this formula here. You don't have to do all that. You get a page of notes. Shut up. Write down the cosine double angle formula. You're only going to do the first or the second one for these problems because you only want to have one trig function. So I want to use the first one. And you say, well, wait a minute, why not use the second? Because if you look, I have a cosine x. So I only want cosine x's. I don't want a 2x and an x. I just want cosine x. So that's why I'm going to use this double angle formula with the first one. If this were a sine x, then I would use the second one. I would replace cosine 2x with the second one because I only want sines and I don't want a sine 2x. Well, if it were a sine 2x, we use a different identity, but I don't want sine x and a cosine 2x. I only want all sine x's. All right. So in this particular case, I'm going to use the double angle for cosine and I'm only going to stick to 1 or 2. Okay. So that's what I would put in my little page of notes for this section. And so let me create my little box around it. So those are the two that you really only need. Okay. All right. So let's go on to the next page and finish it. All right. So I would have cosine of 2x minus root 3 cosine of x plus 1 equal to 0. Let me make sure I copied it right. Rewriting the cosine 2x using the formula that only has the cosines in it. It's going to be 2 cosine squared x minus 1 minus root 3 cosine of x plus 1 equal to 0. And that's from rewriting the cosine 2x. Now I only have cosine x, cosine x. Granted, it's squared here, but I only have cosine x. But here I have a -1 and a +1, so it's going to cancel. And when those cancel, the ones are going to cancel. That's going to leave me with, welcome so much. I think it's Cassidy. Thank you for joining us. So then you're going to have 2 cosine squared x minus root 3 cosine x equal to 0. And then I'm going to factor out a cosine x and any other constants that are common. But in this particular case, we only have a 2 and a root 3, so there's nothing else common. So let's go ahead and factor out the cosine x. So then I'm going to have 2 cosine x minus root 3 equal to 0. And I always like to do a little mental check. If I take cosine x times 2 cosine x, that gives me 2 cosine squared. And if I take cosine x times the subtracted root 3, that's going to give me the subtracted root 3 cosine x. So I factored it correctly. Now that I've factored it, I'm going to set each factor equal to 0. So case 1, I'm going to have cosine of x equal to 0. So I'm going to introduce again that unit circle. whenever the cosine or sine are equal to 0 or plus or minus 1, then I know that that's going to give me a quadrantal angle. And a quadrantal angle is an angle that's on the x-axis or the y-axis. Okay. So I'm basically asking myself, where on this unit circle is the x value 0? So the x value is 0 at this ordered pair, 0, 1. And this ordered pair, 0, -1. So that's going to give me the angle. I'll do the first one in yellow, green. So that's going to give me the angle in green. And that's going to be represented by, let's make it as well. That's going to be represented by pi over 2. Then I'll do the next one in blue. And that's going to be the angle 270 degrees or 3 pi over 2. Each quarter or each quadrant intercepts this arc of pi over 2. So here you have pi over 2, 2 pi over 2, 3 pi over 2. So that one's going to be in blue, and that's 3 pi over 2. So I know that x is going to equal pi over 2 or 3 pi over 2. And that's from my first equation. And then number 2 is from the second factor, 2 cosine x minus root 3 equal to 0. So 2 cosine x minus root 3 equal to 0. Since this is a linear equation, i.e. the cosine is not raised to the second power, we're going to solve for cosine by adding a root 3 and dividing by 2. So we get cosine of x equal to root 3 divided by 2. I know that cosine of 60 degrees, because I've memorized that, is 1/2. So therefore, it must be the cosine of 30. But if you don't have that the cosine of 60 is 1/2, what you can also do is you can draw a triangle, or is what some students do, they have some special angles. So I draw the triangle because I can't reproduce a special angle chart in a calculus class, and they're going to expect you to know special angles, and they're not going to expect you to have a chart with those angles. So it's not a good habit. If you have that unit circle thing, I would, it's okay to memorize the first quadrant and then just use the plus or minus, but the whole thing, no, that's, you'll be forever. All right, but if you were just going from this, you would say, okay, I'm going to have an angle X in the first quadrant where the adjacent side is root 3 and the hypotenuse is 2. And you say, well, wait a moment, why do you use the adjacent and the hypotenuse? Well, I do that because I remember that the cosine is adjacent over hypotenuse. That's true for cosine. Okay, so that's why I have the adjacent of root 3 and the hypotenuse of 2. So now I recognize that it's a 1, 2 square root of 3 triangle. So this side here must be 1. And so since this is 1, the smaller angle between 30 and 60 must be that angle. So that's why x is equal to 30 degrees. Because x is opposite 1 and 60 degrees is opposite root 3. I said x is opposite 1. Maybe I meant to say it's opposite of 1. Yeah. Well, yeah, no, x is the angle that's opposite 1. That's okay. All right. All right, so now we know that x is 30 degrees. It turns out that's not the only place, though. Where else is the cosine positive? Well, it turns out the cosine's positive where the x is positive, and I mean x on the x-axis, not x the angle. So x is positive in the first quadrant, and x is positive in the fourth quadrant. So not only this angle here, X, but this one as well. Now the Y is negative, but we don't care about that. So that's also true. So that's the case in quadrant 4. So to find that angle, it's in quadrant 4, and we know that the reference angle is 30 degrees. So to find the other value of X, theta is equal to 360 degrees minus alpha, which is 360 degrees, minus 30 degrees, which is 330 degrees. And 3 goes into 33 11 times. So we have theta equal to 330 degrees is equal to 11 times 30 degrees, which is 11 times pi over 6, or 11 pi over 6. So our two answers are going to be X equal to 30 degrees, which is pi over 6, or 11 pi over 6. So for case 1, we got 2 values. And so we also got another 2 values for all values of X. We got 0 degrees. Excuse me, we got pi over 2, 3 pi over 2, pi over 6, and 11 pi over 6. So go ahead and substitute our answers on Alex. So we got pi over 2. Let's pause it. Since this one had infinitely many solutions because it wasn't restricted, so I do want to make sure that I also add all the multiples. So I added a 2 pi k to each of the answers. So plus 2 pi k. So 2 pi k. However, the first two, you really could combine them. If we go back to our picture of the unit circle, because that was that quadrantal angle, it turns out to go from pi over 2 to 3 pi over 2 is just a difference of pi. And then to get back up to another possible answer, you would add another pi and then keep adding pi. So you could rewrite those 2 answers. I'll go back and share so you know what 2 answers I'm talking about. You could write these 2 together as one answer. You could write this as pi over 2 plus pi k, not 2 pi k, but pi k. So by adding a pi revolution each time to pi over 2, you'll pick up this one. But I think they'll let you slide if you don't catch it. So we'll check our work. Wahoo, and we got it correct. So let's go back to 6 because there was a similar question, I think, about this on 6. No. Let me read the question again about 6. Also on 6, how the heck do I tell? Oh, if he wants me to do multiple answers. Okay, so I got it. So on this one, it's not like they want you to do multiple answers. It means that there are possibly more than one answer. And you're supposed to know how to determine that. And the way you do that is you go over that handout on the law of signs. But even if you went through it and you still weren't clear, let's go ahead and do that one now. So since that one was number 6 on my stuff here, oh man, it's all out of order. Oh. Here's number 2. I'm just looking at my slideshow on my, I'll let you see what I'm looking at. Maybe you can help me catch it, make sure I'm not doing something crazy. Yeah, so I'm at 4, but then it goes back to 2. Oh no, that's case 2. Okay, that's number 9. Okay, 9, that's all of 9. I got it. So it wasn't this isn't number 2, this is case 2. Let me write that down. So you know what I need to do? Not have that circle around it. So case 2. Okay, good. I was all freaked out, thinking everything was all out of craziness. All right. Since infinite solutions, no restriction. Then our answer was pi over 2 plus 2 pi k, where k is an element of z, 3 pi over 2 plus 2 pi k, where k was an element of z, pi over 6 plus 2 pi k, where k is an element of z, and then 11 pi over 6 plus 2 pi k, where k was an element of z. Wahoo. All right, now let's go ahead and do 6. So since 6 is before 9, I just want to get my ducks in order. I want to try to put them as close as I can in order. All right, so number 6, I'll just draw the picture. So don't laugh at my picture, it's beautiful. Let's see. And then they tell us little b is 58. And little b is opposite b. And then it tells us little c is 66. I hate when I'm sloppy. And angle B is 41. So when you look at the original problem, this is what they have. But when I drew it, I wrote down the angle measure for B. And then I wrote not just B, but I said that it's equal to 58. And then here I wrote C equal to 66. So when I drew it, I made sure that I incorporated that information. I'm much more visual, so writing the information up top kind of would make me a little bit cuckoo. All right. So on this problem, it does not say how to do this. It doesn't say use the law of sines, use the law of cosines. It's not a right triangle, even though my picture looks like it's kind of right. Let me draw it better. No way. Well, that makes it look even more right. Whatever. It's not right. Okay. It's not a right triangle. But I do have an angle and I have a side opposite. So anytime I have an angle and a side opposite, then I know that's a case for the law of sines. And then the fact that I have another side as well lets me know that that's the case where I'm going to have an ambiguous case. Because if I have two angles, you only can have one possible third angle. But when you only have one angle, you could have, it could be some cases where you could have one answer, no answer, or two answers. All right, so the first thing I would look for is that I have an angle and a side opposite. So whenever I have an angle and a side opposite, you want to look for the law of sines. So you have the sine of, so since we have also little c, let's start off with sine c. That's the one we don't know. So we're going to do sine of big C over 66 is equal to sine of 41 over 58. So I chose the angle and then the side opposite. To solve for sine of C, I'm going to multiply both sides by 66. So I have sine C is equal to 66 times the cosine, times sine of 41 over 58. When I solve for C, I'm going to do that by taking the arc sine of both sides. So I have C is equal to the arc sine of 66 sine 41 all over 58. Sometimes you'll also see it written as sine inverse. Either one is correct, so they're not incorrect to interchange them. So either way is right, sine inverse or arc sine. When you take the inverse of that angle, this is the crucial step. You might get no solution. You might get one solution. And then to see if you got two, you have to do some work. So you say, well, how do I know which one it is? Well, if you take the sine inverse on the calculator and you get an error message, that's the one where there's not possible. We couldn't find C. So let's go ahead and go out to our Alex calculator and see if that's the case. So I'm going to plug in that value, 66 sine of 41 all over 58. Oh, I should have put the inverse sine in first. Oh well, that's okay. I'll double click or highlight that whole thing and hit sine inverse. Now I got the sine inverse of all that. Hot dog, we call this an angle. They tell us to round the value of that angle to the nearest 10th. Round our answer to the nearest 10th. So if we round our answer to the nearest 10th, we're going to look at the hundredths place. So since 9 is 5 or more, we raise the score. And so that 48.29 is going to round to 48.3. So C is 48.3. So we know we got one triangle, hot dog. Now to check to see if there's a possible second case. And the way we do that is we take 180 degrees minus 48.3 degrees. And the reason why we do that is because there's two places where the sign is positive. The sign is positive in the first quadrant and in the second quadrant, because remember the sign is the y values, and the y values are positive above the x-axis. That's quadrant 1, quadrant 2. So if you know the reference angle, and 48.3 is an acute angle, and the sine inverse will always give you an acute angle because these numbers are positive. So it's always going to give you the acute angle, but there's another angle in the second quadrant that might work. It might work. So let's try it. So we do 180 minus 48.3. So I'll call it C2, just in case you, let's call it theta. Let's call it theta. That way, I think that's what I've done in the past. So let's do 180 minus 48.3 out on the Alex calculator. Make sure I don't make any mistakes. All right, so we're going to do 180 minus u, 180 minus u, and we get 131.7. Okay. So we just want to make sure, will it be possible for us to get a third angle? So if we take 131.7 degrees, and then that 41 degrees that they gave us for B, we want to know if we have a third case. So this one here was B. This one here was a possible case for C, maybe. And then this one here would be A. We know all of those would have to equal 180 degrees. So if we sum those two, the B and the C, and subtract from 180, we might be good to go. And I think we are. So let's go out to Alex and add those up. 41 and 131.7. So you get yeah, it's possible. You get 172.7. So you subtract from A, and you get A is equal to 180 degrees minus 172.7. So what is that, you guys? 7.3? It's a tiny little puppy. I'll just check it out on Alex. So 180 minus 1, yeah, it is 7.3. So I did do it correct. All right, so we are going to get a second case. So let's just work through and find the missing pieces for the first case. So what I like to do is I like to create a little table. It just helps me keep everything straight if I can see what pieces I have and what I'm after. So I'm going to put it over here to the right. And then what I like to do for my table is I like to separate it with angles and with and sides. So on one side is going to be the angles, and then on the other side is going to be the angles. Did I say angles twice? I'm getting tired. What time is it? Yeah, it's 9 o'clock. My bedtime. It's my bedtime, even though I never make it by then, but that's my goal. More like midnight. But at least I'm getting good. I'm telling myself 10 o'clock, stop working. You guys, I've been working, shoot. I'll wake up at 6 in the morning, 7 in the morning, be at this computer till 10 o'clock at night, midnight. I can't do that. 6 to 6 is 12 hours and another 6. Oh, Lord, that's 18 hours. No wonder I'm tired. Plus, I'm not a spring chicken. I might look like I'm spry. Shoot, I ain't as young as I used to be. All right, so we know B is 41. We know we got one value of C, which was equal to 48.3. And then we got A, we don't know. We know that little b is equal to, I think that was the 58 one, wasn't it? Looking back at my picture, 58 and 66. And then I already know that I'm going to have a second case. So let's go ahead and just draw another box. I don't know why I didn't just draw 2 right then and there. That was kind of crazy. Oh, what's all good? It's all good in the neighborhood. Woohoo, la-loo. And that's another thing, when I'm tired, I get silly, which is good. It's better than being mean. So A2 is going to be something. B still the same. It's 41 degrees. And C2, I think we got 7.3. No, I think that was for A. The second case was that 131.7. So maybe I should call that C. I think that'll be less confusing for students. Call it what is, Mom. Call what is. So here's the first case for C, 48.3. This will be the second case. And we know it's a second case if when we add all the 3 angles, the 41, the new possible angle, and A, if they are less than 180, then I know we're good to go. If this happened to be bigger than 180, then it would be only one case, the 48.3. I forgot the value that fast. 131.7. So how do we get the third angle? Anytime you have two angles, please do not use the law of sines or the law of cosine to get the third. Whenever you have two angles, to get the third angle, you just use the fact that all three add up to 180. So sum the two that you have and subtract from 180. So we're going to take 41 plus 48.3 and subtract from 180. So A is equal to 41 degrees plus 48.3 degrees. And then we're going to subtract that from 180. So let's go out to the Alex calculator and get that answer. Oh man, I didn't take my medicine. All right, so we get 180 minus the sum of 41 plus 48.3. And you get 90.7. All right, so let's go ahead and write that there in blue, 90.7 degrees. So now that we have those angles, and then B and C are still the same for the second case, B still 58, C still 66. Now all we have to do is solve for the two sides A. So I need A in both cases. So I need A over here, and then I need A in the second case. All right, so let's find the first A. So I know that A over sine of A, which is 90.7 degrees, is equal to B over the sine of 41. So 58 over the sine of 41. And I always want to use the original values that were given. Notice that B equal to 41, 58, 66, they're the same in both little boxes, okay? So now I'm going to multiply both sides by sine of 90.7. So little a is equal to 58 times the sine of 90.7 degrees all over the sine of 41 degrees. So we'll go out to the Alex calculator and do that computation. So 58 sine of 90.7 all over sine of 41. You get some water while you write down that answer. Oh no, my water bottle's empty. Not quite empty, but it's going to be soon. So 88.4. So I've captured that out on my iPad. And that's finding that first value of A. So we could call that A1, but so A1 is going to be 88.4. Now we need to find the other A. So we're going to do the same thing again. We'll take A2 over the sine of now the smaller angle A, 7.3. I'm just going to write it as A because I can see it's kind of messing up there. So I'm going to do A over sine of 7.3 is equal to 58 over the sine of 41. Multiplying both sides by sine of 7.3, we have A is equal to 58 times the sine of 7.3 all over the sine of 41 degrees. Huh. So we'll go back out to the Alex calculator. And this is the cool thing about using the Alex calculator. If you hit the undo button, only thing that's changed, instead of having 58 sine of 90.7, instead that inside creature is going to be the new angle 7.3. So you just replace it. So if you hit undo, you don't have to type all that stuff back in. And so you get 11.2 when you round to 1 decimal place. So we have 11.2. All right. So I really like having mine in my little angles and sides, and then keeping the one that's all stays the same. The 41 is the same, 58 and 66 for B and C. Same thing for the second case. All right, so let's go ahead and put our answers in on Alex. And then let me just check to see if there's any questions in the chat. No, okay. All right, so for C, we got 48.3. For A, we got 90.7. And then we also got A of 88.4. And then since we got 2 cases, we're going to hit OR. And then we get, for the second C, we got 131.7. And notice that these two differ by 180. That first angle differs by 180. And then 7.3. And then little a was 11.2. And we check our work. Oh, we got correct. All right, so next on our list was 14, 16, and 17. So 14 is the square root of 1 plus sine x equal to cosine of x on the interval from 0 to 2 pi. In this particular case, we have a square root of a trigonometric expression. So in order to free the trigonometric expression, I've got to square both sides. But I know that whenever I square both sides, I have to be careful that I'm not introducing answers that might not work in the original. So when you square both sides, note, check in the original. So we want to make sure we check our answers in the original equation. So let's maybe highlight that in green. Oh, wrong marker. There we go. Whoa, what happened? No, man. The whole thing moved. There we go. All right. So square both sides. So then we're going to get the square root of 1 plus sine x, quantity squared, equal to cosine x quantity squared. When we square the left-hand side, it frees the radicand, that 1 plus sine x expression, from the radical. It says, come out, you're free from radical prison, come out. Just like we're going to be free from school prison in 3 weeks. Woohoo! Shut up. And then on the right-hand side, we can express that cosine x. We usually take that 2 and write it in between the s and the x as an exponent. And that's what that means. That's the same as taking the cosine of the value and then squaring it. So now what we have is a quadratic, but the only problem is I have a cosine on one side and a sine on the other. So just like we did with the double angle identity, where we wanted all sines or all cosines, same thing here. I want all sines or all cosines. So I'm going to use the Pythagorean identity that says that cosine squared x plus sine squared x is equal to 1. So what I'm going to do is I'm going to take this guy, that's what I want to replace. So I have sines. So that means I'm going to solve for this one. So when I do that, I'm going to subtract the sine squared. So let's do that in a little thought cloud too. That's my little thought cloud. She's getting tired. She's being a little silly. All right. And once I do that, I'm going to rewrite the right-hand side where it has just the sine. So I have 1 plus sine x is equal to 1 minus, sine squared x. Now I'm happy. Way to go. Yippee-yi-yay, yippee-yi-yo, because now I only have sines. And in fact, I can cancel the ones if I subtract a 1 from both sides. So then I have the expression sine x equal to the opposite of sine squared x. So I'm going to add a sine squared x to both sides. And I like adding the negative creature. So that way I keep the coefficient positive for the leading figure. In other words, the sine squared term, I want it to be positive. So I'm going to have sine x plus sine squared x equal to 0. Factor out the sine x, and I get 1 plus sine x equal to 0. Then I'm going to set each factor equal to 0. And I should check to make sure I did this right. Sine x times 1 gives me the first one. Sine x times sine x gives me the second one. So that does factor appropriately. So I'm going to set the first case sine x equal to 0. That's asking me where on the unit circle is my, go to my little clip art and pull up my little unit circle. Where is on my unit circle is the y value 0? Because remember, sine is the y. So where is the y value 0? Well, the y value is 0 at this ordered pair 1, 0, and this ordered pair -1, 0. Those two places are those x values I'm after, not the x like on the x-axis, it was x, the arc on the unit circle. You can think of it that way. So I see that that's going to be the case when x is 0, where I don't move at all. I'm going to stay right here at 1, 0. So that's x equal to 0. Or if I traverse the unit circle pi radians, that's the other case, or 180 degrees. All right, so those are the two places where the x is 0. Where the sine is 0, which means where the y value is 0. So when we know that that's going to be the case when x is 0. And then in the second case, when x is equal to pi, or 180 degrees. So our two answers are x equal to 0 and x equal to pi. All right, so the y value is 0. You're on the x-axis. That's going to occur when x is 0 and when x is pi radians. And it's really confusing because you want to think of x as the x value of the ordered pair. That's not what I'm after. I'm asking for the arc on the unit circle such that when I look at those points on that unit circle, the y value is 0. and the y value is 0 here at x equal to 0. That's that arc of 0 where I didn't move at all. And x equal to pi. That also has a y value of 0. So when you see sine equaling 0, that's the same as saying the y value on the unit circle where the y value is 0. And what's the arc that it cuts off? Bam. It would be nice if these were thetas rather than x's, thetas. Then it wouldn't be so confusing, because that is kind of confusing, kind of deep. All right. Case 2. 1 plus sine x equal to 0. That's the same as sine x equaling -1. That's asking, excuse me, -1. That's asking you where on the unit circle is the y value -1. So if I look at this ordered pair here, it's 0, -1. That's where the y value is -1. That's going to intercept an arc, which we call x. Of 3 pi over 2. Since this is on the interval from 0 to 2 pi, I don't have to worry about adding multiples. So then I know that my answers is going to be x equal to, I think that's true. Yeah, it is on the interval from 0 to 2 pi. So we have x equal to 0, x equal to pi, and x equal to 3 pi over 2. Not done. You think you're done. You're thinking, I'm so happy I'm done. No, you're not. Because we squared both sides, you have to make sure these work in the original equation. So the original equation was square root of 1 plus sine x equal to cosine x. And you've got to check each one. You got to check x equal to 0. Matter of fact, let's write it over here. Looks all nice and neat. Oh, I thought that was the eraser. Seriously, dude? So we're going to go ahead and plug in x equal to 0. And we get the square root of 1 plus the sine of 0 equaling the cosine of 0. I don't like my square root symbols, kind of on drugs. It's going to take the square root of the world. And we want to see if that's true, so let's put a little question mark. Okay, the cosine of 0 is saying, okay, if I'm at 0 radians or 0 degrees, if I'm at 0 radians, what's the x value when I'm at 0 degrees? So let's pull up that unit circle again. Am I the only one that's tired, or are you guys night owls? I'm like wore out. Okay. So here I am on my unit circle. I'm at 0. That means I have not moved at all. And the x value of this ordered pair is 1. That's one way to look at it. Another way to look at it is if you look at the cosine graph. The cosine graph does something like this. It starts off at 1. In other words, when the x is 0, the cosine graph is 1. That's another way to look at it. All right. Another way to look at it is shut up, have a chart with the values, since it's open notes. But I'm here to tell you, when you take calculus, that's not going to fly. All right. So you get 1 plus the sine of 0. So the sine of 0 is asking you for the y value of the ordered pair for right here. So the y value of the ordered pair is 0. So you get the square root of 1 equal to 1. Bam, hot dog, diggity dog. It's true. It walks. So x is good to go. Smiley face for the x equal to 0. Now we got to do x equal to pi. I don't want to. So you get the square root of 1 plus the sine of pi equal to the cosine of pi. So we'll go ahead and bring up our little unit circle again. Come here, little unit circle. We need you. We need you right now. We need you right about now. All right, pi means I'm going to be here on my unit circle. So let me highlight it for you in a blue. Come here, little pi. It's hard to highlight 0. All right, so the ordered pair is going to be -1. Let's write it here so you can see it better. -1, 0. So that's my ordered pair. The sign is asking you for the y value of the ordered pair, and the cosine is asking you for the x value of the ordered pair. So you get the square root. I had this freaked out feeling where I hadn't been recording. And I was, so I'm okay. Like it was on pause. It's like, no, no. What am I doing? Oh yeah. 1 plus the sine of pi. The sine of pi is the y value. So the y value is 0. And then the cosine is the x value. So here you get the square root of 1 on the left, which is 1, equal to -1. And that is not right. No, no, no. False. So therefore, this is not a solution when x is pi. So that one doesn't work. Last one to check. What was the last one to check? 3 pi over 2. All right, so let's go ahead and check 3 pi over 2. 3 pi over 2. Bring up our trusty dusty unit circle. You'll just have 1. And I think that would be wise. And if I was in a calculus class, I would draw 1 unit circle at the top of my test, and I would just label the sides. 1, 0, 0, 1, -1, 0, 0, -1. There's nothing wrong with that. All right, so now we're doing 3 pi over 2. So when we're at 3 pi over 2, then we have the ordered pair 0, -1. And we do the highlighter. Now we're looking at this arc of 3 pi over 2. When we ask ourselves 1 plus sine of 3 pi over 2, I'm asking myself, what's the y value of the ordered pair on the unit circle when it cuts off an arc of 3 pi over 2? And the y value on the unit circle is -1 for the arc 3 pi over 2. So it's the square root of 1 plus -1. And then the cosine of 3 pi over 2 is the x value, which is 0. And 1 plus -1 is 0. So you get 0 equals 0. So it checks. So smiley face, that one works. So the only one that didn't work was the case where we had x equal to pi. So our answers are going to be x equal to pi over 2 and 3 pi over 2. I think that was right. Which one got the nix? Yep. Yep. Oh, no, it's x equal to 0. Sorry. I keep getting the eraser mixed up with the highlighter. It's like, really, dude? I need help. Help, I need somebody. Help. You guys have stayed. Oh my goodness. You're troopers. Troopers, I tell you. Troopers. Oops, I thought I had the box. Oh, I had the box. All right, so that's going to be our answers. All right, so let's check that out. Sine of 0 is that y value, 1, I'm at 0, and the y value is 0, 1 plus 0, 1, yeah, that's it, and 3 pi over 2. What time is it? It's 9:25. I wonder I'm white. Whose idea was that? I usually do it from 7 to 9. I should stick with that. I'm just glad I have you on. How about that? All right, so that was 14. Let's go out and do 16 and 17. Let's see if we can whip out these two in the next 15, 20 minutes. All right, so 16. Oh, they're all on the ones on the trig stuff. All right. So the difference between this one and I think it was number 2 was this one is on the interval from 0 to 2 pi, and the other one was infinitely many solutions. Oh, there's something in the chat. Hold on, I missed that. Chat. How do you know when to check your answer and when to check? Anytime you square both sides, you should always check. So it's squaring both sides. Sorry, you sent that message at 9:20. I'm just now seeing it. Thank you. I've got a lot open. I've got my iPad open. I've got Alex open. I've got the Zoom participants open. I've got the chat open. And then I've also got my notes open where you've asked me which questions you want me to work on. So I got a lot of stuff I'm trying to pay attention to. And I'm trying to tell you guys, you keep thinking I'm some spring little chicken. I'm here to tell you, Professor Smith, she may look cute. Yeah. Should see me. I fell asleep on the couch. I'm like, oh, that's what old people do. They fall asleep on the couch instead of getting in the bed. Yeah. And I woke up and my back is bothering me. I was wondering why, because I had to run up the steps because I thought, man, I ain't got a lot of time. I got to get ready for this meeting. I can't be down here with I didn't have on my PJs, but I need to run upstairs and see if I can do something with my hair because I was looking a little scary. I ran up the steps. And then when I got up there, I said, man, my back hurts. Why is my back bothering me? Your back's bothering because you fell on the couch, sleep on the couch like an old lady. You know what? I have not saved this document. Let me save this. Sample test 3, trig. Before, whenever I would hit save, it would save it somewhere. Now it's copying it to some drive. I don't know what I have done. Oh no, it put sample test 3 trig. Lord have mercy. You know, when you do things audio. Let me fix that one. Sample test. Oh, trig is what I was trying to say. Trig. Trig. Where did that come from? I still don't understand that. Oh, well. All right, let's whip out these last two, 16 and 17. Are you getting the hang of quadrantal angles? And that's for when cosine or sine are equal to plus or minus 1 or 0. That's going to be the case. And the other ones are special angles. I haven't had a 45 one yet, though. All right, so this is 19 pages long. Maybe I should open up a new file. All right. Oh, what the heck. 16. All right. So here we have minus sine x plus cosine of 2x equal to 1. So what we want to do with this one, we want to use the double angle formula that involves the sine. So it's going to equal minus sine of x plus 1 minus 2 sine squared of x equal to 1. So if you recall back on, let me find that slide that we had done it on. Let me share my thing. Sorry, I'm not sharing the right thing. So Where was that one where I had the double angle formula? Some of this looks crazy, like I didn't do things in order. I hope I didn't, you guys. I'm too tired to try to figure this out. Is it this one? Nope, wasn't that one. I'm just trying to find our notes. Well, here it is. I found it. I have my little clouds. There it is. So this is problem number 9. So on problem number 9, I had the double angle formula for cosine, and for solving these equations where you either have a sine in the equation as well as cosine 2x, or cosine in the equation as well as cosine 2x, you're only going to use these two because you want to make sure everything has either cosines or everything has sines, and you don't want 2x mixed with x. Okay. All right, so let's go back to our problem. So I replaced this puppy with, oops, I did that backwards. So I replaced cosine 2x with 1 minus 2 sine squared x. Now I'm happy. I'm doing a little happy dance, because I have a sine x and I have a sine x. And granted, the sine x is squared, but it's still the same trig function, same argument. Here I have a different argument and a different trig function. I got sine, and then I've got sine x in particular, and then I have cosine 2x. Different arguments, different trig functions. Can't work with that. They've got to be, well, you can work with it. Now with computing power, you really can. They've got to be the same trig function, same argument. All right, so now what I'm going to do is I'm going to rewrite it in standard form. So I'm going to subtract a 1 from both sides, so the 1s will cancel. Leaving me with minus sine x minus 2 sine squared x equaling 0. I'm going to factor out a minus sine x. Or if I want, I can multiply both sides by -1 and make them positive. Let's do that. So I'm going to multiply by -1 on both sides. So I'm going to get sine x plus 2 sine squared x equal to 0. And then I'm going to factor out a sine x. And then I'll get 1 plus 2 sine x equal to 0. So I'm going to get sine x equal to 0. We've already done that. The sine being 0, that's the same as saying that the y value is 0. So the y value is 0. That means I'm sitting on the x-axis. Sitting on the x-axis, it's going to occur at 0 and pi. And then I'm going to have 1 plus 2 sine x equal to 0, which means that 2 sine x is equal to -1. And that's the same as saying that sine x is equal to -1/2. Well, I've memorized that cosine of 60 is 1/2. But if the cosine of 60 is 1/2, that's the same as the sine of 30. And you said, well, wait a moment, how do you know that? 30 and 60 add up to 90. So that's why they're cosine, because they're co-functions, because they're complementary. Complementary means add to 90. So whenever the angles add to 90, the co-function values will be equal. So I know that the sine of 30 is 1/2 too. So I know the reference angle is 1/2. Excuse me, reference angle is 30 degrees. But I need it to be a -1/2. So where is that going to occur? That's going to occur down here in the third and fourth quadrant. You say, well, how do you know that? Well, the sine is the y value. So the y values are negative below the x-axis. So that's why it's got to be in quadrant 3 and quadrant 4. So my two angles are going to be in quadrant 3 and quadrant 4. With a reference angle of 30 degrees. So for quadrant 3, I'm always going to find theta by doing 180 degrees plus the reference angle. which is 210. And then for quadrant 4, to find theta, it's going to be 360 degrees minus the reference angle of 30 degrees, which is going to give me 330 degrees. So the value for theta is going to be 210 and 330. But they want these in radian measures. So remember the reference angle is 30 degrees. So I just asked myself, how many times is 30 degrees going to 210? So it goes in 7 times, which is 7 times pi over 6. 30 goes into 33 11 times, which is 11 pi over 6. So that's for x. So my answer is x equal to 7 pi over 6 and 11 pi over 6. And then for the first case, I forgot what we got. 0 and pi. So we'll go ahead and box our answers. Good to go. Hot diggity dog. And that's going to be our work for number 16. And where are we at? 9:36. We are cooking with gas. We could do another one. Seven pi over 6. Let's put them in order. 0. Not that it'll mark you wrong if you don't put them in order. 7 pi over 6. Actually, pi over 6 is smaller than that. Pi, because 6 pi over 6 is pi. So 7 pi's. I wouldn't mind a pi right about now. Ugh, I had pizza for dinner. Ugh. I've been kind of eating healthy, you know, with my little salads. I love my salads. Just love them. I make the best salads ever because I put fruit in them. Like I'll cut up an apple or a pear, put some blueberries in there with my avocado and tomatoes and cucumbers and mixed greens. Delish. Pizza. And it was good pizza because I get it from Old Town Pizza in Lincoln. But I don't know, all that bread. Let's check our work. I hope I copied the problem right. Did I have the minus there all along? I did. Okay. I think it's cool that I do the problems live. In other words, I don't know what I'm getting. It's good because sometimes I get stumped and students get to see me think on my feet. I had a professor like that. I'll never forget his name. He was Stavros Buzenberg, Stavros. And he would always say, prove, let's prove. And I remember one time he got stuck, not for long, he got stuck, but it was cool to watch him kind of think through a thing because everybody thinks math people just don't make mistakes. That is so a lie. Math is the place where you make the most mistakes. Actually, anything you learn, you make mistakes. Ask a little toddler trying to walk. They fall down a whole bunch. That's how you learn a thing or two. That's the beauty of math. Sometimes you just get stuck and you have to leave it and come back. Sometimes you have a shower moment. Oh, this is on your test? So all of these are more algebraic. It's the algebra that's messing y'all up. All right, so we have the square root of 31 minus 2y equal to y plus 2. And there's another case, Izzy, where when you square both sides, you need to check the answer in the original. Well, we might not be able to do another one because this one we got to do some work. All right, so we're going to square both sides. When we square the left-hand side, it's going to free the radicand from prison. So that's going to leave us with 31 minus 2y. On the right-hand side, we have a binomial squared. And so we've memorized that it's equal to the first squared minus 2 times the first times the last plus the last squared. And I like doing it with words. You can do the A and B, that's fine, but I like it in words because I can see, ooh, the first term is y. So I'm going to square y. Then the rule says it's 2, take that 2, times the first times the last, plus 2 times y times 2, plus the last squared, and the last is a 2. And the reason why is when you FOIL it out, you're going to get the inside term, which gives you a 2y, and the outside, which gives you a 2y, and you get 2 of the 2y's. So then you get y squared plus 4y plus 4, and 31 minus 2y. So what we want to do now is we want to rewrite it in standard form. That's where we have 0 on one side and everything else on the other. I always like to leave the leading coefficient positive. So just like in that case when I had a minus sine squared x, I added it to make it positive. In this particular case, I'm not going to move the y squared. It's already positive. So I'm going to add the 2y and subtract the 31. So I'm going to add a 2y and a subtract a 31. So add a 2y to the 4y term, subtract a 31 from the 4. So on the left-hand side, I'm going to get 0 equals y squared plus 6y. 4 minus 31, is that 27? Oh, wait a moment. I'm so tired. Yeah. Okay. All right. So then I have y squared plus 6y minus 27 is equal to 0. So I'm going to ask myself what are factors of negative 27 that add it to 6. That means I want two numbers, p times q, that'll equal negative 27. But when I add them, I'll equal 6. 27 doesn't have that many factors. Hot dog, it don't got that many. 9 and 3, 27 and 1. So let's go with the 9 and 3. So 9 and 3, I need one of them to such that they have to be negative, because there's no way you can get a negative 27 unless one of these is negative. One of them have to be negative. And then I want to have it such that when I add them, I get a positive 6. So I'm going to put that minus sign, yes, sirree, right on that 3. That's where you're going to go. So then I got my P is going to be 9 and my Q is going to be negative 3. That's my numbers. So it's going to factor into y plus 9, and that's because I have a positive 9 there, and then a y minus 3 equal to 0. So when I set each factor equal to 0, I get y plus 9 equal to 0, or y minus 3 equal to 0. So then I get y equal to negative 9. I'm just checking the tab. And y equal to 3. So I want you to notice something, that your answers are always going to be the opposite of these numbers. So here we had, let me show what I mean when I say these numbers. Here I have a positive 9, and then my solution is a negative 9. They're opposites. Here I have a negative 3, and here the solution is positive 3. So they're always going to be the opposite of those numbers. All right, so now you think, I'm done, shut up, time to go home. Not so much. Got to check it. Because squaring both sides, you're introducing answers that might not work in the original, might not. So we got right down the original. What was the original? Oh, this was the original. Let's copy and cut it out. There's a little cut tool on explain everything, and it duplicates it. Is that just too cool or what? Go on with your bad self. All right, so let's copy you. Let's get rid of you, dude. You got to go. It's pasted back out here onto the page so I can have my problem. There she blows. So let's check her out. Let's check her out, see if she can work. Can I move it up here? Yeah, beautiful. All right, so let's check. Let's check negative 9. Negative 9 is going to be a problem. I already can see that right off the gate. Because when I plug in negative 9 here, I'm going to get a negative 7. There's no way you can take the square root and get a negative number. This is the positive square root. If there was a minus sign out front, you could. So I know negative 9 is a problem. Negative 9, you are going home. Sorry, dude. Bye. You can't play at the party. All right. X equal to negative 9. Nope. But we'll do a little checky poo. Let me clean this up. It's getting sloppy. You're getting sloppy, Smith. So here we have a double negative. -2 minus 9 is plus 18. So you get 31 and 18, which is 49. And over here you get -7. So you get the square root of 49, which is 7. Sorry. We already said it wasn't going to work. Let's do 3 though. So, oh, this is y, not x. Sorry. Let me fix that up. Let me fix you. I made a mistake. That's a y. All right, so we're doing y equal to 3. So then we're going to get 31 minus 2y equal to y plus 2. So the square root of 31 minus 2 times 3 is 6. See if that's going to work. Oh my goodness. 31 minus 6 is square root of 25. Shut up. Hot diggity dog. It works. Sometimes none of them work. Sometimes neither of the answers work. All right, so then you get it. You're going to get that 3 is the only one that works. So smiley poo for the 3. After all of that, seriously, I could have guessed and checked. So y is 3. Let's check our work. Hey, it's taken a long time. What's up, dude? It worked. 17. Oh, so there's so we didn't do a lot. Okay. So those are all the ones that were asked out on there. I did the law of sines, but I don't think I did a law of cosines one. And I remember someone asking about a law of cosines. So let's see if we can find one that has a law of cosines. Okay. Yeah, these aren't so bad. Matter of fact, I did these on the review on the number 12. That's interesting. 10. Didn't I do something like that? Huh. Oh no, let's label the pictures on this. Let's label the pictures on this. Let's look at 10. All right, what time is it? Oh, we got time. It's 9:47. Yeah, we can squeeze in one more before 10 o'clock. All right. What have I done? I forget what I've done. So 9 would come after 9. I mean, 10 would come after 9. I'm trying to put it in the same order so that when I'm uploading this, if I have to figure out what goes with what, I'll be like, it'll take me forever. So if I have it organized up front, life is sweet. Okay, so that was number 6. So number 6. That's 14. Where's 9 at? Oh, I didn't do it in order. Oh man, you guys, I hope it's not all jacked up. Oh man. If I have the solutions all intermixed, I hate that. I think this is cool. All right, there. I'll just do 10 here. I just got to make sure that I'm adding a page each time and not jacking this up. All right, so what I'm going to do is for this one, I'm going to draw the triangle. Oh, dearie, if you could see what I'm drawing right now, you would laugh. You would say, okay, professor, draw on. But that is a hot mess you got going on right there. They tell me angle C is 101 degrees, and this is clearly not to scale because 101 looks like 30 degrees. A is 59. And then they tell me B is 25. All right, so now what I'm going to do is I'm going to show you what I've drawn, as pathetic as it is, because 101 degrees does not look like that. It doesn't matter. It doesn't have to be drawn to scale. All we need to see is this: hot diggity dog, 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 dog. We have an angle included side, excuse me, we have a side included angle, side. So anytime you have what they call a SAS, side angle, side, I got to fix this. This is a hot mess I got going on here. So anytime you have a side angle, side, that's always law of cosines. I was just trying to clean that up, you guys. It had it looking scary. So S is side angle. When I say angle, it means included angle, side, not an opposite angle. Okay. So anytime you have SAS, that is the law of cosines. All right, so for this one, they're asking us to solve the triangle. So we got to find all the missing pieces. And what's nice is they give us the largest angle. So it's good to go. But what students have done is usually with the law of cosines, once they find one angle with the law of cosines, no, we're not going to find a law angle. We're going to find a side. Once they find once they start with the law of cosines, they'll usually stick with the law of cosines to get the second angle. But in this particular case, you don't have to worry about it because the bigger angle's already given. You're not going to get another case. You already have something. When I say bigger, it's bigger than 90 degrees. So anytime you get an obtuse angle, you're good to go. But if this were 30 degrees, the law of sines might not give you an angle that's 101. It won't. It'll only give you an acute angle. So that's the issue. So moral of the story is if you want to use the law of cosine to find this other angle, you can. Just know that once you have two angles, please don't use the law of sines or the law of cosines to get the third. Use the fact that the angles of a triangle add to 180 to get the third angle. So two angles, use the sum to 180 rule, okay? All right, so let's go ahead and find that missing side C. So the law of cosines looks a lot like the law of Pythagorean's theorem. Pythagorean's theorem says that a squared plus b squared is equal to c squared. The only thing with the law of cosines, it adds in a little funness, 2ab cosine theta. That's one variation on the theme. And then all you have to do, is that right? That's not right. Sorry. It's a squared plus b squared minus 2ab cosine c equals c squared. So sorry. So sorry. I just teach the class. I don't do the problems. So I'm a little rusty. So that's one variation. The other variation is b squared plus c squared minus 2ac. Notice here, the two sides should be the same. So it should be bc, sorry. So it should be 2bc cosine of a equals a squared. So notice that you have the angle a and little a. Whoa, whoa. And the other one is I've got a and b, I got b and c. How about a and c? So a squared plus c squared minus 2ac cosine of big B is equal to little b squared. All right, so that's going to be the law of cosines. That's the case where you're solving for a side. The other case is when you're solving for an angle is that you would subtract the c squared, move it over to the other side, move the 2ab over, and then divide by 2ab. So this is what it looks like if you're solving for an angle. Cosine of c is going to be a squared plus b squared minus c squared all over 2ab. Cosine of b is going to equal a squared plus c squared minus b squared all over 2ac. And then what I'm doing is whatever this letter is here, big B, that's what I'm subtracting squared over here, little b. Whatever's in the numerator, two of those puppies are down in the denominator. And then cosine of A is going to be B squared plus C squared. That's everything but A, B and C, minus A squared all over 2BC. All right, so since we're solving for little c, we're going to use the first formula. We have 5 minutes. And that's why you have to use this formula, because you have the side, and the included angle. So if we go back and look at our picture, A was 59 and B was 25. So A was 59 plus 25 squared minus 2 times 59 times 25 times the cosine of 101 degrees. So in order to find C, we'll take the square root of all of that. So we have 59 squared plus 25 squared minus 2 times 59 times 25 times the cosine of 101. Double click, that highlights the whole expression, and then take the square root. And so you can see we have the square root of all that madness. And you get 68.329. Round your answer to the nearest tenth, so 68.3. So now when we find the other angle, you can use the law of sines. It's a lot less work to use the law of sines to find the other angle, but a lot of students, they will just use the law of cosines again. So I'll show you what I mean. So if we go back to our picture, we now know that this side here was equal to 68.3. Let's make that blue. I always like to draw the derived colors in a different, the derived values in a different color. So what they'll do is they say, well, look, so let's find this angle A, because now we have all the sides. So the rule says that the cosine of A is equal to B squared plus C squared minus A squared. Notice little a is what's squared and subtracted, and whatever is the two positive squares is going to go downstairs, so 2BC. And then you just plug in the values. So then B squared was equal to 25 squared. C squared, we just derived it. It was 68.3. Minus A squared, A was the 59. All over 2 times the two numbers upstairs, the 25 and the 68.3. And then let's just take the cosine inverse of that. So what I do is I usually will put the top part in, the argument in, and then I'll highlight it and take the cosine inverse, sort of like what I did here. I put what was in the radicand, and then I highlighted it and took the square root. All right, so then I'm going to take that 25 squared plus 68.3 squared. Oh, you know what? I better keep that 68.3 to I better keep that 68.3 to 4 decimal places. Otherwise, I'm going to get it wrong. I sure am. I'm going to get it wrong. So I'm going to write that down, 68.3293. 68.3293. And then when I'm doing the when I write my answer, I'll write 68.3, but computation wise, I better do it to 4 decimal places. All right. So 3293. I'm just making sure in my notes that I'm writing down the 3293. Somebody said, I have to go, Professor. I can't take it. If you have to leave, it's okay. It's after 9. It's actually 10 o'clock. All right. So let's go ahead and write that now. So I'm going to take the 25 squared. Put that first. So 25 squared plus 68.293 squared minus 59 squared divided by 2 times 25 times 68. You know what would have been a good thing? I should have stored that. That's 68.3293. All right. And then I'm going to take the cosine inverse of that. It's in degrees, so it'll give me my answer in degrees. So I put in the quotient first and then take the cosine inverse. So then I'm going to get 89.7. And that's going to give me A. To find the other side, I probably would use the law of sines. It's just easier to do rather than to use the law of cosines, but you can either way, especially since they give you the obtuse angle. Once you get 2 of the angles, I would definitely not use the law of sines or the law of cosines to get the smaller angle. So I'm going to put in the 89.7. I'm going to put in B, which is going to equal to 101, because that's the angle that they give us, plus 89.7. We just derived it using the law of sines, cosines, but you could do it with cosines. I'm going to add those up. Something's wrong. Let me make sure I did that right. Make sure B was 25. Let me just make sure I copied it right. Yeah, B was 25. B was 25. Little c was 68 point.
Someone just wrote in the chat, it looks like the decimal is off on the bottom.
Oh,
There it is.
thank you. I've been there for an hour trying to find that. I told you I'm out of steam, man. Thank you. I'm thinking, why the heck? Thank you. 57.95 or 58.0. Okay. That works out. So then when you do 58 plus 101, you get 159. All right, now when you subtract that from 180, thank you. I said, we want to go home, Professor. Cannot be having you lagging 21. And then little c was 68.3. All righty then. So I think we've got it, but we could have done the law of sines to get that 89.7. But, since you have the calculator, I don't think it's as painful. So start with the law of cosines, find the law of cosines for the second angle. And then once you get the two angles, use the other one. So let's check and make sure we got it right. Round your answer to the nearest 10th. Am I on drugs? Oh, no, this should be 58.0. Sorry. And all righty then. All right, my friends, I think that'll be it. I think I answered all your questions. I have office hours tomorrow at noon from 12 to 1. And also on Thursday from 12 to 1. You probably will have taken the exam by then, but just in case you haven't. And you can always text me. Sometimes it's just a little question. Is this what you meant when you said this? So you can always shoot me a quick text. So thank you so much, whoever let me know where I went astray. I really appreciate that. So I'll go ahead and stop recording.